Question 7. Prove that any natural number x is divisible by 9 if and only if the sum of the digits of its decimal representation is divisible by 9. We represent x in decimal form as an minus 1, and so on as far as a1 and a0. So these are the digits in the decimal representation of x, which of course means that x must be equal to, well, the first digit an times 10 to the power of n plus the second digit an minus 1 multiplied by 10 to the power of n minus 1 plus, and so on as far as a1 times 10 plus a0. That's what decimal notation means. Now, 10 is congruent to 1 mod 9, and that implies that all of the powers of 10, so that's 1, which is 10 to the power of 0, and 10, and so on, as far as 10 to the power of n minus 1, and 10 to the power of n, all of them are congruent to 1 mod 9. So if we start with 10 to the power of n is congruent to 1 mod 9, well, that implies that what appears here, an multiplied by 10 to the power of n, is congruent to an mod 9. 10 to the power of n minus 1 is congruent to 1 mod 9. That implies that what appears in our decimal representation, an minus 1, multiplied by 10 to the power of n minus 1, that is congruent to an minus 1 multiplied by 1, which is simply an minus 1 mod 9, and so on, until 10 is congruent to 1 mod 9 implies that a1 times 10 is congruent to a1 mod 9, and of course a0 is congruent to itself mod 9. And if we add all of these together, we get an multiplied by 10 to the power of n plus an minus 1 multiplied by 10 to the power of n minus 1 plus a1 times 10 plus a0, and all of that must be congruent to an plus an minus 1 plus all the way down to a1 plus a0 mod 9. In other words, x is congruent to the sum of its digits mod 9. So x is divisible by 9 if and only if x is congruent to 0 mod 9, if and only if an plus an minus 1 plus down to a1 plus a0 is congruent to 0 mod 9, if and only if the sum of the digits of the decimal representation of x is divisible by 9.